Hey class, so welcome to snow day number 2 of the year, e-learning, here we are. A couple of things, let me make sure, hopefully you're already on Canvas, right? You're watching this video. So watch the video, when the video is over, then complete the worksheet. You do not need to print it. If you want to print it, by all means print it, but don't feel obligated to. You can just make a quick table on a sheet of paper and just sort of make a quick coordinate plane. I'm not worried about how perfect your coordinate plane is. Just graph something, it's fine. So guys, whatever you sort of need to do to just get a quick graph it is fine for your homework. So we're gonna, once you finish that, right, then you're gonna answer a few questions in the Canvas quiz to make sure you understand the information. Make sure we have that for attendance purposes, and then we'll go over everything when we're back at school, hopefully, on Friday. Okay, so today we're gonna look at graphing exponentials. So we've talked about graphing quadratics. Now we're going to talk about graphing exponentials. And when we're graphing exponentials, this is the form that we're going to be looking at. Okay, so you'll probably want something to sort of write this down so you have it as notes, enough to at least help yourself as you're going through and doing the worksheet. Okay, so y equals a, b to the x plus c is our exponential sort of form that we're looking at, where A is actually going to do the same thing it did with quadratics. A is going to tell us if the exponential opens up or if the exponential opens down. And same rule with quadratics. If it's a positive, it's going to open up. If it's a negative, it's going to open down. Now, we're not going to get the same shape that we got with a quadratic. Instead, with an exponential, I don't really have a better word for it other than we sort of get this swoop thing that happens, right? I know my fancy wording. So this is what it's going to look like when it opens up. This is what it's going to look like when it opens down. Okay, now that could sort of be flip-flopped either way, but that's our up direction and our down direction. Okay, and then C, here's a great math term. C is going to be what we call our asymptote. I did not pick that word. I don't know why it's so strange. And our asymptote is going to be a line that we can't cross. Okay, and as we sort of start going through and looking at a couple examples, I'll be able to show you a little bit better of what that all means. Okay. So let's say we want to graph an exponential. Maybe we have something just very simple like y equals 2 to the x. Okay, just like when we're in standard form, we don't necessarily have this perfect way of graphing exponentials other than falling back on that basic making a table, plugging in some input values, and getting some corresponding output values. When we are graphing exponentials, I'm going to ask you to do at least 4. You could do more if you're trying to get a better picture. Okay, and you need to get values that will fit on the graph. So make sure you're not making numbers that are too large, that they won't fit on like a 10 by 10 grid. Okay, and then it just comes down to sort of ease of picking things. I'm going to pick some very specific points to get us started here. Let's plug in -1, 0, 1, and 2. Okay, and you can use your calculator to help you do this, or we could use our rules from our properties of exponents, right? So if we take 2 to the negative first power, we said a negative exponent told us to flip it to the other side of the fraction. Okay, but if we were to check that and type into our calculator 2 to the up caret -1, right? 0.5, which is 1/2, right? It's that 2 is getting moved to the denominator. It would be fine if you put 0.5 there if you wanted to work in the decimal. Okay, 2 to the 0 power, right? We said in our exponents unit, anything to the 0 power is 1. 2 to the first power is going to give us 2. 2 squared is going to give us 4. So just like everything else we've been doing, once we sort of get a table, we then know that these are ordered pairs. So this is the point, -1, 1/2. 0, 1, 1, 2, and 2, 4. Okay, so now I can just plot these points. -1, 1/2, right? I have to kind of approximate that one. 0, 1, 1, 2, and 2, 4. Right, so we should sort of be seeing this swoop that's happening in here. Now, before we draw that in, remember I said there's this weird thing that we call an asymptote that is actually one of the most important parts of exponentials. Okay, that asymptote is a line that we can't cross. So on this problem down here, what we really have is y equals 2 to the x plus 0. Okay, this tells us that we have this sort of line happening at y equals 0. Right, y equals 0 is a horizontal line. Okay, so you don't actually have to draw this every time you graph, but you do need to like realize that it's there. And what it means is that when we draw our graph, we can't cross that dashed line. Instead, what's going to happen is we're going to continue to get closer and closer and closer to it. Because if we plug in -2, we would get out 1/4, right? -3 would give us 1/8. We're just going to get a tinier and tinier and tinier fraction. So we actually have a swoop that's happening right here. Now, it looks a little bit hard. I mean, you can't tell that you're getting closer and closer and closer, but you cannot cross that line. Okay, so when I'm grading these, what I'm going to be looking for is that you've completed a table, okay, with correct input and output values, that you've graphed those points, okay, that you're making this general swoop shape, but that you're not crossing the asymptote. Okay. So, right, that's just sort of our first one. Let's look at another one and sort of see how that goes. So maybe let's say we want to graph y equals 2 to the x plus 1. So very similar to what we had before. So we'll make a table. Have some 4 input and output values. Again, I don't necessarily care, just like anything, as long as you're plugging in input values that fit and are giving you a picture. I mean, you could plug in 49, it's just not going to fit on your coordinate plane. Okay, so maybe we plug in -1, 0, 1, 2. Okay, so again, we're doing 2 to the -1st. Plus 1. If you want to use your calculator, you can. So you could do 2 up caret -1 plus 1 gives us 1.5. Just like we did with quadratics, right? If you move this up here and change it to a 0. Okay, 2 to the 1st power is 2, plus 1 is 3. 2 squared is 4, plus 1 is 5. Okay, so now if we start plotting these points, we'll have the point, let me make sure okay, we'll have the point here of -1, 1.5. So again, I'm going to kind of have to approximate. 0, 2. You could just draw a quick coordinate plane, guys. Like, just draw a quick coordinate plane and, right, put some tallies in there. It's okay if it's not perfect, enough for you to sort of see that swoop. 1, 3. 2, 5, right? So we can see our swoop happening here. And we want to make sure that we're not crossing our asymptote, right? Which is y equals 1. So that means right here at y equals 1, we can't cross. So we can't go any lower than that. My swoop isn't very good, but that's okay. I would still give you full points on that. Okay, what I don't want to see is you giving me something that's going down here. Okay. So then we can have all sort of different things happening when we're graphing. It's still the same concept. We're still going to just sort of plug and chug and see what we get. So maybe we have something like y equals 3 to the x minus 7. That's a y. Again, we'll make a table to get some good points to plot. Okay, if I start plugging in -1, I know that's going to make it 1/3. That can start to get a little bit tricky to plot, but it really doesn't matter. Okay, so if we're using our calculator, if that's what you would prefer to do, subtract off. So I'm going to get a -6.6 repeating, or a -6 2/3. We'll have to approximate that when we graph it anyways. Okay, maybe we do 0, which will give us -6. Right, 3 to the first is 3. Minus 7 is going to give us 4, -4. Plug in 2. 3 squared is 9. 9 minus 7 is 2. Okay, so we'll just start plotting. -1, -6 2/3. 0, -6. Oops, sorry, I might be off the screen there. 1 comma -4. 2 comma +2. Okay, we want to make sure we don't cross our asymptote. So our asymptote here is -7. So that says when we look at our graph down here, right, as we go to graph this, sorry, my camera's kind of bouncing here. We want to make sure that we don't cross this -7. So our graph's going to come across here. It's getting super close to -7, but not actually crossing it. Okay, and that's what our graph should be. Okay, let's look at another one. We're almost done here. So let's say we want to do something like y equals -2 as an a value times, how about 2 to the x power plus 1. Okay, so we know that this should have an asymptote of 1. We also know maybe that this should open down because we've talked about that as an a value, but the process of graphing it is still going to be the same. We still just want to plug in some input values and get some corresponding output values. Okay, so maybe if we plug in -1, so right, if you're using your calculator, you have to be kind of careful here. So -2 times 2 to the -1st. Okay, it's going to give us 0. Then maybe we plug in 0. Do 1 and 2. Okay, so if we plug that in, or sorry, take those points and start plotting them, right? We'll have points of -1 comma 0, 0 comma -1, 1 comma -3, 2 comma -7. So this one opens upside down. So our asymptote up here, right? Our asymptote is still at y equals 1, a horizontal line at 1, right? We can't cross 1 up here. We're just making our swoop upside down, and I'm not as good at drawing them upside down, but oops, pretend I hit that other point. Okay. So just be prepared as you go through your worksheet. You might have to make bigger or smaller numbers. Like let's say we wanted to do something like y equals 4 to the x power. And we start plugging in -1, 0, 1, 2. Right, as soon as we plug this 2 in, we get out 16, which is way too big. Right, so just like we did in our functions unit, we just want to take this to a smaller number. Okay, so don't use 2, plug in -2. But of course, as soon as we do that, we start getting weird decimals. That's okay. right? You're just gonna have to sort of approximate, do the best you can. What I'm looking for, like I said, is making sure that you are not crossing whatever your asymptote is, that you're making a table with correct output values to find the correct points on the line, and that you're getting that swoop shape. Okay, so complete the worksheet, whether you print it or do it on a separate sheet of paper is fine, and then make sure you complete and submit the Canvas quiz for attendance. Hopefully I'll see you all on Friday. Bye, guys.